Okay, so for the first sets of problems, I'll give you equations kind of like this for number 66, where it says r equals 8. So what we're trying to do is describe the graph of a polar equation where r equals 8. And the thinking is similar and different to rectangular equations, where it's similar to rectangular equations in the fact that we want to graph all points where r equals 8 is analogous or a very similar question to graph all points where x equals 8 or y equals 8. So if I think about all the points where x equals 8 in rectangular form, that would be a vertical line, because if you move up and down, x stays the same. So we have a vertical line, x equals 8. Same for like y equals 8, that would be all a horizontal line because you don't move up and down at all, you only move left and right. So now we got to think in terms of polar. We want to graph every single point where r equals 8. So let's say I have one, or let's say these 2, 4, 6, 8. Let's say this is 8 right here. So if I graph that point would be where r equals 8. If I went up here, if this is 8 as well, that would be r equals 8. This would be another point. This would be another point if those are all a distance of 8. But we need to think there's more. So the way that this is the same is that we want to think the same as we did in rectangular form, but it's different because our coordinate system is a different setup in polar form. So we have to think of, we don't want the radius to change. Our angle can be whatever, so we could rotate any value we want, but we want to stay on the scale for r of r equals 8, which would be a circle. So r equals 8 would be a circle with a radius of 8. That hopefully will help you with your thinking for the other first sets of problems on the homework. Okay, now we're going to move on to some of the problems from the worksheet. So for the homework, you are doing the odds. I'm going to go ahead and do the couple evens. So in this first part, change each to a polar coordinate. Let's go and look at number 3. So for number 3, first r, I'm going to do the square root of the value squared. And note, I can suppress the negative and really don't. Actually, I'm going to put parentheses around that, given we have the 2 and the root 3. Don't have to put it here. Could if you wanted to. R equals, I'm going to give myself a little more room here. So when I square this, I get 2 squared is 4, root 3 squared is 3, so 4 times 3 is 12, plus 2 squared is 4, which gives us root 16, and root 16 is equal to 4, so I have my r. Now I'm going to go with tangent inverse, and this is really the reason I want to do this problem. I have negative 2 root 3, whoops, sorry, I got to go y over x, not x over y. So I'm going to go 2 over 2 root 3. And note, which simplifies to be, note, I really don't have to take into account the negative because our goal here is to get a reference angle. I'm also going to show you how to do this graphically. This is going to equal our reference angle. And whether we have a reference angle in the first quadrant or the fourth quadrant based on our inverse rules, again, it's just a reference angle. We got to figure out what quadrant the rotation is and use that reference angle to find the actual rotation. So the fact that if I find the reference angle whether it's positive or negative doesn't really matter. In fact, it's a little easier being positive in the first quadrant. That's why I made it just a positive 1 over root 3. So I look at that and I go, okay, so y numerator over x numerator. 1 is going to be the y numerator. Root 3 is going to be the x numerator. That gives me the coordinate root 3 over 2 comma a half, which is 30 degrees, or pi over 6. So I have a pi over 6 is our reference angle. And then I look up at number 3. I look at the actual problem. And the actual problem is negative 2 root 3 up 3. So that puts me into the second quadrant. And if I have a reference angle here of 30, I then know that my rotation is 150 in radians would be 5 pi over 6. So again, our radius was 4, so I'm going to put a 4 here, and then our rotation is 5 pi over 6. We have to have an angle between 0 and 2 pi, and a positive radius would be preferred. And the second method is really what I just showed you by if you graph the actual point right here by going over 2 root 3, you'd have a negative 2 root 3 and a 2 here. And then you would try, from that you can try and recognize what the angle measure is based on the relationship of the right triangle. If we saw this as root 3 and this is a 1, or multiple of that, we'd see that, that this is a root 3 and this is a 1, that's a 30, 60, 90, and opposite of 1 is 30. You get this reference angle, and then you know this is 150, which is the same as 5 pi over 6 in radians. Let's go ahead and take a look at number 4. If I have negative 8, 0, anytime we have a quadrennial, I just simply like to graph it. So if I have negative 8, 0, that would mean negative 8, 0 over there, right, where this is a length of 8. So we have to ask ourselves, if I'm in polar, because this is in, wait, what is this in? Yeah, change it to polar. Okay, I just got confused by the directions below. Okay, so if that's rectangular, we go, okay, well, how would I get that polar? Well, the goal is you start from here and rotate to point the arrow. So now the arrow's pointing that direction. You would have to rotate pi for that. And now, since the arrow of your radius is pointing in that direction, I would go out a positive 8. So that coordinate would be positive 8 is how far I go out with a rotation of pi. Okay, so now moving on to 7 through 11, where you are going from polar to rectangular, and as we had in the notes, I'm going to do number 8 here. The calculation to go from polar to rectangular is simply using our x equals r cos and y equals r sine. Pretty straightforward. Just literally plug in. So r is negative 2 cosine of 5 pi over 4. And also we'll check it just by using our logic and understanding of the two forms to see if they reasonably match up. So let's go and do that, those calculations. First one, cosine 5 pi over 4 is a pi over 4 in the third quadrant, so that'd be cosine pi over 4 is root 2 over 2, and it's in the third quadrant, cosine is negative. So it would be, we have that negative 2 out front, and then cosine would be negative 2 root 2 over 2. And then we can simplify that. The 2's cancel, the negative cancel. So that gives us an x of root 2. Y, we have negative 2. Sine pi over 4 is the same. Y value at a pi over 4 is root 2 over 2, and it's in the third quadrant, so that's negative. And so that would also give us a root 2. And so this is telling us that our coordinate is root 2 comma root 2. So let's imagine if we graph root 2, root 2. That would be right here where this is root 2, this is root 2. This is just a check. You didn't have to do this. It'd be a 45-degree angle. Let's go ahead and check this polar. Well, if I did polar, I'd rotate 5 pi over 4, which is pointing the arrow in that direction at the 45 degree. But it's a negative 2, so we would go in the opposite direction, 2. So that would be our point. And this would be a 45-degree rotation right here, just because this would be 45 degrees as well. So yes, those two match up. Let's go and look at, yeah, I think that's good for those. Okay, change polar equations. You have that 9x squared plus y squared. Let's look at what that would look like. Let's change this up. So I'm going to go with 16x squared. I don't know how these numbers are going to work out. Plus 25y squared equals like 144. Let's see how this works out. So I'm going to plug in our cos theta for x, and I'm going to plug in our sine for y. I change it up because I want it to look more like the problem you have to do. 144. And then I have 16r squared cos squared plus 25r squared sine squared equals 144. And so we're going to factor out the r squared. So if I factor out the r squared, we end up getting 16 cosine squared theta plus 25 sine squared theta equals 144. And there's really not much more I can do here in terms of trying to isolate that cosine square plus sine square, which we know would equal 1 if we could isolate it, but we can't. So I'm going to divide by all of that because all of that's being multiplied by r. And not very satisfying answer, but it is nonetheless. Oops, it should be a sine square there. Nonetheless, that's what we have for this one. Okay, I'm going to get you started on this one. I'm not going to go through all of it. But we have a little more going on here because we have an r squared and we have a sine term, but it's a sine 2 theta. And we don't have any conversions for sine 2 theta. So first my thought is let's get rid of the 2 theta and let's get it down to just a theta. So if we want to do that, we can use our double angle formula, which gives us r squared, and then our double angle formula is 2 sine theta cosine theta. Here we have an example of where a formula, a double angle formula, has nothing to do with like a double rotation and trying to find a ratio of a single rotation or vice versa, but it ends up helping us solve an equation, something we prior to doing this may not thought before. So again, some of the reasons why we learn certain skills at some point. So now we look at this and we go, okay, I need the r's next to the sine and next to the cosine. I have an r squared over there, so maybe I should divide by the sine and the cosine. But that would be a problem because then we have r's, r squared over sine and cosine rather than multiplied by it. So the only way that I can get r's over there is if I multiply by how many r's I need. I need an r for the sine, I need an r for the cosine, so r times r means r squared. And I distribute that in, that gives me r to the fourth, which equals 2. And note, r squared means r times r. And I'm going to write this where I'm going to put the r with the sine and an r with the cosine. And now we have 2xy or 2yx, and over here we have an r to the fourth, which I suggest writing like this, because we know what r squared is. So over here we'll have 2xy, I'm just writing that in order, in alphabetical order. And r squared we have is x squared plus y squared. So we're going to have the square of x squared plus y squared. And after you do that, go ahead and try foiling out and move everything to one side.